research is not everyone's favourite thing. So because of that, I've tried to make it as accessible as possible. It's not that no one can do it. Everyone can do research. It's just, you know, how much you get into it, I guess. And so being really into it, let's get started. So just to start off talking about, I guess, a little bit of philosophy to get us all warmed up. You know, what is real in this world we live in? And this is a quote from The Matrix, a great sci-fi movie that I really love. And it's talking about, you know, how do you define what is actually real? If you're talking about what you can taste, what you can feel, and then that's just electrical signals that are interpreted by your brain, and your brain interprets them and then says, you know, that's what you think is real, okay? So really interesting way of thinking about the world. And then that's one of the reasons why we really need science, particularly in behaviour, because, you know, our brain, when it's interpreting the world, it actually has biases in the way it sees things, cognitive biases. So, you know, there's about 12 categories I found on some of my research, but it depends how you define them. There's a lot of different categories of bias and different ways you can look at bias. And essentially it alters the way that we perceive reality. And so it's really important to have science because we can't trust ourselves. We need something more concrete to latch onto to know what is actually real in the world out there. And, you know, particularly in dog behaviour and veterinary behaviour type areas where, you know, things have changed a lot in the last 20 years and because of science. So we need to keep going with that. So one nice, commonly well-known bias to start off, I'm going to go over a couple quickly, is confirmation bias. So there's all this stuff we see in the world, facts and evidence, and we've got certain beliefs, and if the evidence lines up with our beliefs, we notice it and it confirms our belief, right? And that's a confirmation bias. And we tend to ignore some of the things that don't agree until it's like, oh, that's funny, and then just forget about them. But then when things do agree with what we already believe, we tend to latch onto them and remember them. I'm not saying that, you know, oh, you guys have all got bias and I don't. I have it. I'm very aware that I have it. I probably have it, or I know that I have it when I don't know I have it. It's that pervasive. We all have it, and it's not good or bad. It just is. It's part of being human. Another example of bias is self-serving bias. So a good example of this is like maybe you've used some medication on an animal to try to modify its behaviour, and you get positive results. You're like, yes, this medication is really good. This is awesome. It's a medication. You use the same medication maybe on another animal, and then it doesn't work. And you're like, oh, look, maybe it was the owner this time. It wasn't the medication. Medication's good, but it was the owner. So you've got to be careful about this sort of biases that self-serve to show that, you know, what you did is the thing that helped rather than just getting better on its own. Another bias is called the Dunning-Kruger effect. And here's a little quote by Socrates. It's, I am the wisest man alive, for I know one thing, and that is that I know nothing, okay? And what this is getting at with the Dunning-Kruger effect is that the more you learn about a topic, a field, an area that you study and over time, the more you realise that it's a lot more complicated than it seems on the face of it. And so this bias is to when you're looking into a new topic or not something new that you're not used to, you look at it, we all tend to oversimplify things, and it's the only way we can understand them is by simplifying it. But it's just another important bias to realise that, you know, a lot of the things in the world are much more complicated than we actually realise. We tend to dumb them down. And I'll be touching on all these, I won't mention them later, but there will be examples of how science helps to, you know, move away from these biases throughout this talk. Another example is declinism. This is kind of just like when you don't like change, you already understand how the world works. Why would you bother going through the effort of trying to figure out a different way of thinking of things? So maybe a trainer 20 years ago that had learned dominance theory, they're not going to really, some of them might not want to learn about new theories that could explain dog behaviour. So they already know it. Okay, so what do we do? How do we know what is real? We need something, okay? And we can't just use a whole bunch of anecdotes, all right? Because we're all going to be having these biases when we're using these anecdotes. And we'll find other people that have had the same biases, done the same things, we'll form groups, and we'll just all get carried off in the wrong direction. We need to know what's actually real, okay? And to know what's real, we need actual data, okay? It's not just a bunch of anecdotes. It's different. So you get data, scientific method, Okay, so not going to go into too much detail on this. I'm sure you all know about this process, but think about it maybe as testing reality, testing what's actually going on, trying to figure out, what is reality, how do animals actually behave, what's actually going on. So, easy, observe, question, hypothesis, prediction, experiment results, easy, right? It's actually not that easy. It takes a long time to do a study. I'm going to go over a little bit about the kind of things that you have to go through. And after you get your results and the statistics, okay, this is a big hurdle. I'm going to touch on statistics, but I've been assured that I presented this to my wife before, and she said that she hates statistics and that she was perfectly happy with the level I went to. So please don't be scared off. It is required to draw conclusions from data. Okay, it's a really useful tool. And this little cartoon here. This is a bar graph, and these are error bars, and these error bars tell you how much variation there is in the data. So the top of them is the mean. So here's an average of 50, but because you've got a really high hat with a big T, there's a lot of variation in that data. So these other measurements are saying, we can't trust you. You've got too much variation in your data. You're obviously you're not nice and clustered around a point. You're not a good mean. It's a bit mean. All right, and then finally, after that, then there's peer review. Okay, so doing a study can take a long time, and then you get to peer review, and then, it can be pretty hard going through that process. We'll talk about it a bit more. Okay. So, quick little background to my research. Did a PhD looking at predisposing factors to anxiety-related behaviour problems in dogs. That was the title. Went for quote-unquote 3 years at Melbourne, but probably went over to 3.5. It can be difficult getting it done in time. There were 5 main studies that I did, and 4 of those got published, so I was pretty happy about that. But each study required a lot of steps. So there's like 8 steps I've got here. There's a little bit more, but each one of these can easily take a month. So you've got to understand the field you're going to be doing your study in first, a lit review, hypothesis of what's going on, formulate an experimental design, so designing a study. Then if you're doing a study in animal behaviour, you quite likely will have to go through some ethics. Okay, so you've got to justify the use of any animals you're going to use. Sally understands the difficulty of this, going through this with me last year, or the year before, I think now. Yeah, so it can be pretty taxing to go through all that. You need to do some statistical planning, including a power analysis, which we'll go over a little bit later very quickly. And multiple rounds can be quite taxing. But then once you get through that, it's very important to get through that. You then go and acquire your test subjects, which can also be quite difficult. And then after that, you perform your experiment. A whole bunch of issues that can go wrong there, unfortunately, technical, logistical, animal, people issues. After all of that, analyse your data, see what you got. Have you got any good results? Write your paper, submit to journal, then peer review. Okay, so these things, they're big efforts, big efforts. And a problem up here can have ongoing effects all the way down the chain. So I'm going to go over one of my studies very briefly, just the interesting bits for you, so I don't bore you too much. But in this one, it was published in the Journal of Vet Behaviour, actually, and 783 dog owners questioned, which was a feat in itself, getting that number. All young dogs were questioned, and the owners have all acquired them at under 10 weeks old. And they'll ask a few questions about socialisation. So the age at which they first walked their dog and started to socialise their dog in public areas, right? And then the number of dogs that their dog met per week, the time spent with them at different times, trying to get a gauge of the age that they started socialising and how much they had, okay? Then I also asked a tricky little question, which is, did they actually restrict the socialisation of their own dog because it was already fearful or aggressive at a particular young age? Were they already showing signs of fear or aggression that made their owner decide to socialise it less at that young age? And then finally, whether now their dog ever displayed any true aggressive behaviour. So not play aggression, or actual aggressive behaviour to unfamiliar dogs on walks or out in public. Okay. Then we did some statistics and we found some results. And we found owners were starting to take their dogs out into public at around 13 weeks. And half of them, this was before their final immunisation of their primary immunisation course, which I thought was interesting. In a third of responses, participants reported they had seen their dog display aggression towards another unfamiliar dog. And that's in line with other research that I've found from other labs around the world. And then finally, and this is a really important point here, owners did restrict the amount of socialisation that their puppy received because of their puppy's own behaviour in 32.6% of aggressive dogs, okay, compared to only 9% of non-aggressive dogs. So what that means is that an owner's got a puppy maybe 10 weeks old or something, and it's barking at other dogs, already fearful maybe, or growling in the park. And then the owner says, oh, that wasn't so good, we're not going to take them out as much, okay? Or avoid that from happening again, okay? So then if you're going to then be claiming causation in any socialisation study, you've got to look for this, because if you're finding that all of the aggressive adult dogs have been socialised less in the study, what if the owner socialised them less because they were aggressive? You can't claim causation then, right? Correlation is not equal to causation, okay? And then I kept on going through the data, and I found that for each additional week that an owner waited to socialise their dog in public, the odds of the dog being aggressive were reduced by 4%. Okay, so by socialising them early in public, it was more likely that the dog was aggressive. And I just thought, what is this? This can't be right. This is not what I want. This does not agree with what I've learned, okay? And I kept going through the data, and I had a look at the effects of age, of breed, of puppy source, of physical discipline, restriction. They all were pointing in the right direction, but this thing was pointing backwards. I mean, it's the whole reason I did the study. I wanted to check this. I thought no one's checked this. That's why I want to do it. And it was pointing the opposite direction of what it should have been. I thought, oh, made a big mistake. I must have made a mistake. And then I thought, well, wait a sec. Maybe the study's right and I was wrong. You know, we do this to test reality. That's why we do our science. Maybe my idea was actually incorrect. Maybe what we're thinking is wrong, okay? So how could we explain this then? How come owners socialising their dog in public earlier are more aggressive, the dog becomes more aggressive, okay? So I thought, okay, well, maybe it's a little bit more complicated than we actually thought. Maybe younger puppies are more sensitive to negative social experiences as well as positive, right? We socialise them young so they can have positive experiences and remember it. Well, maybe the early negative experiences are very memorable too. And because most dog owners are not dog behaviour experts, they can't shield their puppies from negative experiences in public. And they're having these lasting bad experiences that scar them for life because the owners don't know how to do it properly. So maybe our message of telling owners to socialise their puppies in public at a young age is actually making things worse on average. Right? That's pretty shocking, right? I did not expect this till we did the research. I had no idea that owners could be getting the wrong message. I don't know, that we need more study to be sure about this, but it's pointing to something a little bit worrying, right? And there are a few people that contacted me after this and like, wow, that's pretty shocking. We need to be more careful about how we put this message out. And I still see today that, yeah, the message is not nuanced enough with this. So yeah, that was exciting. That was me testing reality and finding that, no, the world doesn't work as simply as you think it does, Dennis. So yeah, research in veterinary behaviour is good. It's required to understand what's real in practice. However, not all research is necessarily good, right? We need critical thinking to be sure that we can understand, that we're reading a study that's okay. Okay. So this is the way my mind goes through how I feel like I can critically review something if I'm doing a good job. Okay. I don't feel like I can really do a really good job of critically reviewing a study if I don't understand the subject matter and the experimental design really well. And then obviously the results and statistics. Statistics can be a tricky one. Sometimes you've got to do a bit of extra research to really understand that. And then at that point, you can critically, well, I find that I can really understand a study properly to fully evaluate it. It's what it means to me. Okay, so I'm going to go over some examples now of ways that I use to critically review the literature in animal behaviour. And yeah, just some different examples of critiques that can be used and the pros and cons of them. Okay, so first up, poor spelling and grammar. You know, these things happen, particularly in an international research audience. Okay, so when I'm reviewing research papers, often they're from other countries, so English is not their first language, and so they have quite a few problems trying to convey what they mean in English, but the studies can still be really good. Definitions or terms can be incorrect or misused as well. This is a common one that people pick up. And, you know, it can be quite problematic. Sometimes it's just because the scientific meaning of the term is different to the non-scientific usage. If you look at it, just one paper in isolation, and you see a term like, no, that's a bit funny, but you realise that maybe there's 100 other papers that all use it and they all know what they mean. Maybe it's just not what you think. And then it can also be quite problematic also if something's really not defined well. Like, for example, a reactive dog. I've spent a while trying to look through the literature a few years ago to find a good definition of a study measuring reactivity. There's nothing out there, so it's not a well-defined term in the scientific realm. Okay, so another common critique that a lot of people have is that the group sample size is too small in a study, so not enough subjects, right? I see people saying this when they are reading another paper and trying to analyse it critically. Also, authors talking about their own study as well. So just to demonstrate, you know, how to know whether this is the case or not, quickly, we're going to go over a quick hypothetical study. It's an extreme example, just to make things clear. In this study, we're talking about, there's an experiment where we're giving dogs a treatment injection or a saline injection, okay? And we're going to measure the body temperature of the dog 6 hours after the injection is given, okay? And we're testing the hypothesis that treatment changes internal body temperature in the dogs. And the sample size is 3 dogs per group, 3 dogs in the treatment, 3 dogs in the saline, okay, 6 dogs total. All right, question, is this sample size too small? Okay, so in front of your computer, just put up your hand. If it's too small, no one will see you, but then at least you know that, you know, that's what group you're in at the moment. And we'll go over this a little bit more now. So how do we know that it's too small? Okay, we need to not just say that it looks small, but know, all right? So why do we care about size at all? Because if the treatment changes the body temperature in this study, we need to have the numbers to get statistical significance when we do a statistical test later on to figure out if the two groups are different statistically, right? With this P of 0.05, that's the 5% chance of getting a false positive, basically. And so you need to do a statistical power calculation to be sure that your N is low or high or sufficient or whatever. We need to know what the minimum number of patients we need in each, or sample in each group. So the terminology is power. So an 80% power means that we'll find significant results with that number of animals in each group 80% of the time if the treatment actually works, if it actually does change the body temperature in this case. Okay. So that's not perfect. You could do the study and you might not find anything. And we're planning to use a 2-sample t-test. Okay. So the power of a study the power of the study is determined by the effect size. Sorry, tongue-tied. So how much might the temperature drop? So if it's a really big effect size, you need less animals. The variance of the data, if the data is all clustered well together within group, if they're all very similar within each group, again, you don't need as many numbers to find significance when you do your testing. And the p-value, how sure do you want to be? If you want a p of 0.05, okay, that's fine. If you want a p of 0.0001, you want to be really sure you're going to need more numbers. Right? So let's plug in the numbers here. So in this extreme example, the treatment was actually IV lethabar at 1 ml per 2 kilos. So very unethical, don't do this, but you can see why the treatment dogs are pretty shocked now. And the effect size that then we need to detect is from 38.5 degrees down to 20, so room temperature, once they're dead, unfortunately, over 6 hours. And then the variance of the data is pretty small, like most living dogs, around about 38.5 plus or minus 0.5 standard deviation. So that's like 34% on either, 68% of dogs are in that one standard deviation, right, within 38 to 39 degrees, right? So pretty well clustered. So yeah, when we plug in the numbers, actually we only needed 2 dogs in each group. Okay, the reason, and this was actually with 100% power with an N of 2. Why? Because there was such a large effect size and such small data variability. Okay, really unethical study, but very well designed in terms of accuracy and finding differences between groups. Okay, so sample size was not too small. 1 extra dog was actually given length of arm. Okay, so think about that. Now, so just moving on from that, I guess it's a commonly used criticism, but it's also overused a bit. You can't be sure the sample size is too small unless you actually run a power calculation. So in that study we just talked about, had 100% power, which means that if 100 labs around the world did this study, they would all find statistical significance. Okay, you didn't need more than 2 dogs. They would all find significance. They'd all find the effect. So there's no point in putting 3 dogs in the groups. Okay, so it's often blamed for lack of effect when maybe the study might have been adequately powered, but it was due to other problems with design, like maybe there was too much variation in the data, not enough confounding variables were accounted for. And low numbers is actually really good for animal welfare when you're talking about animal behaviour, as long as the study is adequately powered. You don't want to use excess animals because you don't want to put them through research unnecessarily. So more examples of critiques are experimental design critiques. So moving on, but related to the last one. So reasons why you might think you need more numbers, but you don't, is that maybe you haven't searched for those confounding variables, like the one I talked about before with dog walkers that have got aggressive puppies, not taking them out as much and therefore not socialising them. So these confounding variables that might hide true effect. Incorrect methodology, too many variables being tested. Retrospective versus prospective. Obviously, when you're looking back on something, you're going to have much more chance of having these confounding variables. Whereas if you're doing prospective with a randomised trial, there's less chance that you're going to have all these confounds. That's why it's such a good gold standard way of doing clinical trials. Okay, correlation is not causation. Some of you might be reading this. It's pretty funny little comic I found. So a good example of this critique, this is a good critique. A lot of studies claim this when it's not true. So commonly in our field of animal behaviour, de-sexed dogs behaving worse than entire dogs. So this, correlation between behaviour and de-sexing. Very common one I see. So I'm going to run through an example study. I haven't named it because there's quite a few out there that make exactly the same mistake, and I don't want to single this one out. But basically the premise of this is that many dogs have difficult or problem behaviours before de-sexing, and this causes many owners to go on and de-sex the dog, rightly or wrongly. And if you're a vet in general practice, you'll know that. You hear owners often say, oh, well, calm him down, I'm going to de-sex him because it's too crazy. Very, very common to hear that. And so we know what happens, right? And then these poorly behaved dogs are moved from the entire group of dogs, so the uncastrated group, to the castrated group of dogs by the owner, right? Because of the behaviour, not the other way around, okay? So over time, here's an example of the study. So 35 dogs in the entire group, maybe just say 5 to 6 months of age, again here, 5 to 6 months of age in the castrated dog group. So they're done, around that age. And then in time, some of these dogs have issues, right? And more of them get shifted across. So in the end, because of behavioural reasons, a bunch of these dogs, instead of being in this group, they get pushed over into this castrated dog group, okay? So at the start, maybe at 3 months of age, you had 12 dogs in the dogs that were entire, that had behavioural issues, behaviour problems. And then over time, 5 of them get shifted across. Now there's only 7 dogs out of 30 that have got behavioural issues. So it goes from 34% of dogs down to 23%, right? Because the ones that had the issues are de-sexed and pushed into this group. And then these dogs that are castrated, again, same as entire dogs originally, 34% got behavioural issues of some sort. And then after castration, same 34% plus the additional 5 that have been pushed over from these ones because the owners castrated them. So you end up with 38% of dogs in the castrated group with behavioural issues, right? And so what that means is that there's a 15% difference. So after the owners castrate all the dogs with bad behaviour, the castrated dogs have got more bad behaviour, right? There's a 15% difference in these percents here, right? So the same, yeah, so basically this correlation is not causation. It's actually the other way around. So the bad behaviour causes the desexing. The desexing does not cause the bad behaviour. Just in this case, I'm not saying that it can't, that it doesn't in other situations, but just using this little thing here, you can see that it can look like that, right? And the same study that I used these numbers off, that I got it from, that found that owners are doing this, used the final numbers. They didn't even account for it, right? So didn't account for it, and they said that there was a 5 to 12% increased proportion of castrated dogs and concluded causation, when their own study showed that there was about a 15% difference when I reran the numbers. So this is a good critique that you can have of studies out there. A lot of them claim causation, and you just can't often. You really can't unless you're doing a prospective study. Okay, so this got me thinking. I thought, okay, this is kind of funny. So what if the other reverse was true? What if owners believed that desexing made behaviour problems worse, right? Not better, as a result maybe of reading the study, for example, the castration study, and then they flipped what they were doing and only the well-behaved dogs were desexed, because poorly behaved dogs, they didn't want to desex them because they didn't want them to be any worse behaved, because that would be worse for their behaviour, right? So if that happened and we reran the study, we would actually find the opposite. We would actually find that desexing made behaviour problems improve, right, if we did the same flawed analysis. So I thought that was kind of fun. But it could flip back and forwards over time if people believe the study. Okay, so on to another one. So another thing I really like doing when I'm critiquing papers is finding alternative interpretations of the data. So I really like this study, this looking at effective gentling on puppy development. So gentling is the handling of puppies for 5 minutes per day away from their mother. And yeah, when they're really young, days 3 to 21. And there were 2 groups in this study, and puppy litters with or without gentling, and then they measured the behaviour at 8 weeks. And they found basically that the handled puppies were calmer when they were tested later on, okay? So they found that, the inclusion of gentling during early puppyhood would be advantageous to the emotional development, right? Maybe because of tactile stimulation that's helping out in those early weeks, helping with their development, their neurodevelopment. Okay, so that's what their conclusion was. However, my alternative interpretation was that, look, there are similar studies in rats, actually, that have found a different possible cause. So in rats, the early handling of pups also reduces the development of fear responses, but there tends to be a lot more behaviour research in rodents than there are in dogs, like way more. So there's a lot more to draw on. They've found that the effect is mediated through an increase of maternal care on the pups following the separation. So the researchers took the pups away, put them back, and the mum was fussing over them more. They measured the amount of fussing, like the nuzzling, the licking, and the nursing and the cleaning. And that was much more increased in the animals that were taken away and then put back. But extended separation overcame that. It was really stressful. So 4 hours, not good, okay? But 5 minutes was good in these rats. So yeah, in the gentling study, they attributed it to the tactile stimulation, right? Rather than changes in maternal care, which they didn't actually measure. So a few things out of this, right? Beware of extrapolation, like more stimulation might not be better. You don't want to be gentling these puppies for 6 hours a day thinking, wow, they're going to be really calm, right? And then also, in terms of prospective future studies, it might be really interesting to look at the manipulation of canine maternal care. If we can get mothers to fuss over their puppies more and give better maternal care to their puppies, will they grow up being more calm, more relaxed, less prone to getting anxiety disorders? That would be really great, something that could be looked into. Another critique that I really like to do is seeing the good in the research despite the bad. Okay, it's very easy to pick all the things in research that you don't like about a paper and say, oh, this is bad, this is bad, this is bad. It's not good for all these reasons, but there's always something good in there. And if you can't find it, it's not looking hard enough. So as long as the research team is honest, I don't believe there's anything as a study that's all bad. it can be not particularly useful, but you know, there's often something to take away from it. So don't just look for the problems. A really nice example is this study that I reviewed a couple of years ago about alloparental behaviour and pup-adult interactions. We did this in our Behaviour Journal Club as well. And yeah, it was performed by non-veterinary dog behaviour researchers, and there are a bunch of issues in this paper. English was their second language. It was not very good. Issues with terminology and definitions, experimental design, statistics. Despite all that, I helped them get it through to a point where I was at least happy for it to be published. And yeah, partly because of things like this in here. Like, one thing that I found, and this that I never knew before, was that from 41 breeders that responded to the questionnaire, 18 breeders reported observations of other, i.e. not the mother, dogs, providing food by regurgitation to the puppies in their homes. Okay, so dog breeders, they've got puppies, and then like another male dog cohabiting or another female dog cohabiting with the mum, are feeding the puppies by regurgitating to them. And this is common. I had no idea. No one in Journal Club knew. All of these vets with members, none of us knew it. And I was like, wow, that's amazing, you know. And that's pretty much it. So thanks for listening, everyone. I'll stop screen sharing now and we can have a chat. And yeah, if anyone wants to have a talk and ask some questions or something, I'd be keen.